So we're on to our last session. We've talked about the use of physical technology on locations to reduce emissions. And now we're going to talk about everything that we get out of that physical technology and all this data that's living up in the cloud somewhere. So I'd like to welcome up our first panelist who's going to give a presentation, Alberto Alva from Process Ecology.
Thank you, Blake. And thank you everybody for staying here. Okay, so now we're going to be talking about data, and let me just say a few words about who we are. Again, we've been in Calgary since 2003, so over 20 years. And one obvious application of data that we've been working with our clients for many years, 15 years, is regulatory compliance. So that's a big part of what we do. Just gather all the data from facilities, process the data, generate the reports, ensure compliance. The other big portion of our activity is process engineering. So that's been a nice kind of combination, because once we've seen the compliance status or some risks in some of the facilities, then we can bring the process optimization, process modeling, even technology evaluations, all that engineering work, to help them find solutions for those situations. And we do all this by developing software, which is mostly what I'm going to talk about today. Data, it's almost software always related. Let me skip on this, and I'll start just a few industry challenges. And maybe this is a little bit more history, but we've been doing this regulatory reporting, which is pretty detailed. If you look at Directive 60 and all that, it takes a lot of data to try to come up with these reports. But then, of course, with the advent of these new technologies, sensing technologies, airplanes, we talked about it, sensors, everything else. Then there was this question as to, okay, why are these sensors detecting much more emissions than what's being reported to governments, right? So that debate started happening, and we started learning more about why and how these sensing technologies were seeing emissions. One typical example that I can think always was the tank emissions. When a tank is equipped with a vapor recovery unit, the regulation simply said 0 emissions, right? Don't report anything because you have this technology installed, and that was good enough. But then, of course, once you start looking at it in detail with instantaneous measurements from the sensors, then it's like, well, okay, it's not 0, right? So there are some emissions coming from these tanks, even though they're controlled. So what's going on here? And for us, it was, okay, look, let's first of all not compare a regulatory report that is done on an annual average with an instantaneous measurement, because it's never gonna work, right? So anyway, that's what drove us to start looking more and more closely into this tank emission situation. The other thing that we were noticing once we started digging into that was, again, the sensing technologies are getting really good. Those sensors are good at detecting methane concentrations. However, and I've said this a few times, you detect the methane, and then you need to quantify how much is coming out of there. And of course, that's an estimate. You need to do some atmospheric modeling. We saw some nice, digital twin models, wind speeds and all that, to try to identify, first of all, where is that coming from, and how much is that flow rate. So again, there were some uncertainties there. And again, they're great, they're getting better all the time, but I just always want to make that difference. That's not, I heard it called as direct measurement versus engineering estimate, and I'm saying, hang in there, they're both estimates, okay? Just say that. And then, of course, the regulations are changing. The best example here is the BC regulation now that is calling for continuous monitoring of control tanks for methane, right? So again, that's those methodologies we've been using for regulatory reporting. They did their job, but it looks like they're not good enough anymore. Right, I'm just going to skip this. So this is where we are at, yeah? We are been working with modeling facilities since we started. Again, the purpose initially was design new facilities, the bottleneck plants, optimize operations. That's why we were building models. But now what we're talking about is using models as digital twins. And I heard, and there's different definitions. For us is that first principles simulation model of a facility, right? That is tracking molecules, that is tracking thermodynamics, fluid flow, heat and mass balance, all these different engineering concepts we use in simulation. So again, we don't need more data. More data is good, but as long as there's insight, right? Because there's already a lot of data in these operations the data is not being used really. And if you think about an operator, looking at their DCS screens, there's thousands of tags at these facilities, and nobody can or is tracking them in any detail. It's only when something goes wrong, exceptions, then they become useful. But there's not a lot of good use for this data. And because of that, the teams are reactive. We've talked to several process engineers, facilities engineers. They're looking after several gas plants. Again, they're just trying to prioritize where to spend their time because there's so many situations happening all the time in these facilities. So again, let's say they're running less than optimal in general. Yeah. A few other trends, senior experts, somebody mentioned new talent coming into the industry. There seems to be, an exodus of people retiring and maybe taking with them all this expertise and not enough, new talent coming in. So that's another situation. So again, these approaches we've been using for reporting, for regulatory, are falling short of what is needed now, especially in the context of what we heard of 75% going for the next level. That's not going to be very useful. So let me talk about this solution we've been working on. And again, I'm going to refer back to the ETC because that's been great. Again, working with the ETC team, with Tourmaline, supporting this type of software development and application. And I'm just saying here, in the top is what we used to do for regulatory reporting. Have your inventories of sources and talk to operators, get the data, operating hours, loads for engines, all this data, spreadsheets flying around. Even with some automation, it was pretty slow. But again, because we're talking about one report a year for regulatory, that's, that was working. But now what we're talking about is more getting closer to real time. And the one thing that we realize is that all these facilities are packed with sensors for process control, the SCADA systems, the DCS systems. There's a lot of process data that's been there, that's already there. And we have not used that as much as we should have. So now we're saying, okay, look, let's start pulling that data into a process model, a detailed digital twin in that sense, a process simulation model, and then use that to track real-time the emissions patterns of these facilities. Yeah. So that's our proposal. Again, we use heat and mass balance, thermodynamics, and all the basics of process engineering to come up with these models. We use machine learning where required. And I'll talk a little bit about AI because everybody does, so I need to say that. But I'll say how we're doing it, we think a bit different. And then, again, cleaning your data, all those things need to happen before you can make good use of that data. So, yeah, this is, again, Tourmaline, ETC, West Wolf Lake. We've been deploying there for 6 months, maybe a bit over 6 months there. Catching the data and using our platform to track emissions, specifically from tanks. Again, that's been an interest, looking at tank venting. Again, those continuous monitoring tools are helping, comply with all these new, even voluntary certifications that are popular across the world, not just in Canada, but also our own regulatory regimes. So there's a picture, another picture of the same thing. Again, we've been fortunate I say, because this facility, like was mentioned earlier, is already equipped with a bunch of technologies, right? So there are point sensors on those tanks. Of course, there's the perimeter sensors detecting methane. And then we deployed our modeling tool, which really covers the whole facility, right? So that model is catching the whole facility, but at least we would have a couple of interesting validation points for comparison. You know, what's the model doing? What's the sensor saying? What's going on there? So here's the example of the tank. I'll just say, you know, here's typical tank. Like you can see on the top, there's a compressor tied to that. This is the vapor recovery unit. And it's got a pressure sensor on it. Tanks also have their level controls, their transmitters for levels. And then all this information of the flow rate, pressure, temperature, composition into the tanks at any one time is coming from the model, from thermodynamics, heat and mass balance, all the things that I was saying. So we have all this information, and then because we're pulling that data from the SCADA system, let's say a 10-second frequency. So now we're running these models every 10 seconds, and we also added, of course, the relief devices in these tanks, right? So you have a PVRV, you know, possibly protecting your tank, thief hatches, which are relief devices to protect your tank. And on the right, you can see the light blue is kind of the tank level going up at a certain rate, and then the spiky line is the pressure, right? So then what we realize is, okay, you start building the pressure in the tank, the VRU cannot really withdraw all the vapor that it needs to. And remember, VRUs are usually not designed for peak flows. There's a capital consideration there. So it starts building up the pressure, and then it relieves. So that's where the PVRV is opening. It opens, relieves, and then starts building up again, opens, relieves. Every time this device is open, which is what they must do for protection, there's an emissions event, right? There's some methane puff going up into the atmosphere, and that's what we're tracking with this model. At high frequency, we can see when those devices are opening, relieving the pressure, coming back. Yeah? The thief hatch, similar situation. So once we have this model set up, then we can, again, that's just overlaying the quantification. Because again, based on, you know, vapor-liquid equilibrium, thermodynamics, every time this device opens, we know how much methane is going out into the atmosphere, and we can just integrate across time to determine how much methane is being vented from this control tank. Yeah. So again, that gives you a better idea of what's really happening, the dynamics of the process, and why things are creating emissions. Right. Here's just a very quick comparison for one day between what the sensors were seeing, what the tool was predicting. So again, you know, hard to see in this scale, but many times we both detect. We see detections from different technologies from our model. Many other times, again, we don't see the sensors picking anything, but yet in the pressure profiles, we think or we know something's going on in the tank, even if the sensor cannot see it. So again, this needs more analysis. This is just a very simplistic illustration, but again, when we all agree, something's happening there. And I'll show you an example of some interesting observation there at West Wolf. But before that, let me just also add this thought. Again, the digital twin, the model we're using, catches the whole facility. So we have the complete process context, right? The sensors, they're really good at detecting methane, yeah? And even send an alarm, that's great. But now we know what's causing some of those events. And many times, like I said, it's just a pressure relief, which is what should be happening. So again, it's not that a crew has to go to the plant to fix something, right? It's doing what it should be doing. And that's the reason of the event. And these platforms allows us to identify the root causes for those events. Again, not just methane, but why methane, and not just there, and then what to do about it, yeah? And I'll show you a quick example here. Here is the water tank. You know, we're tracking pressure, then we see that spike, and we detect that there's been a venting event from that tank at that time around 12 p.m. Then you start looking upstream, again, because we have all the process context, and then you see it was filling up. The blue is the level. It was filling up at kind of slow pace, and then it suddenly started filling up very quickly. So now the vapor space is reducing very fast. The VRU cannot handle that. Then the PVRB opens emission. Yeah. So we start, and then you go even back upstream, and you start trying to track the liquid flows from the inlet separator. And sure enough, I mean, it's not super clear, it's noisy, but you do see a bit of a spike in the liquid from the inlet separator. We validated that with the temperature of the inlet separator. We knew that the heater was running at the same duty for that separator. So that drop in temperature, that increase in flow was revealing a liquid slug hitting that facility, right? So now we're saying, okay, that's the reason that your tanks are venting. You're getting frequently liquid slugs into this inlet separator. The tanks get overwhelmed. You're creating emissions. And again, in terms of root cause analysis and mitigation actions, again, we're still in discussions with the operators, but you could look at the control parameters of the level of the inlet separator, and even things like coordinating with the field, because we think this was related to peaking schedules, right? So again, better coordination with the field for peaks into the facility, reduce the number of slugs and the size of the slugs that hit the plant, better control of the flows, lower emissions, right? So this is the type of things that we're seeing. We've quantified this for a few months, and based on what we're seeing, the tank emissions due to liquid slug could be around 40% of the total tank vent for that time period. So again, in principle, you can reduce or eliminate 40% by looking at your control systems and again, your peaking schedules. I just wanted to share with you this interesting example. You see the light blue is, again, the level, and then it drops. So the tank is getting emptied, right? So you see that liquid level drop quickly, and we don't see anything. The pressure, if anything, is lower. So maybe there's a bit of a vacuum when you're sucking the liquid out, and yet the sensors are detecting methane from the tanks, yeah? And we see that as a pattern. It just happens and happens when you're emptying the tank. So we're saying, well, what's going on there? After a little bit of investigation, then this is the case. We understand that this liquid is being trucked out of the facility, and then when you're emptying the tank into the truck is causing the emission. And that's what the sensor is detecting. It's not a tank emission, it's a truck emission, right? So again, we're able to start seeing and differentiating these different source types, which would require different actions for mitigation. Again, lucky that this facility is super well instrumented. We went back and tried to get some data using the timestamps, and sure enough, you see the methane plumes coming from the trucks and not from the tanks. So again, this ability to go super granular, 10 seconds, SCADA models, SCADA data, process models, and then seeing those patterns, we think is very powerful. Right, the last thing I'll say, because with data, we process that data in a process model. It's a big database, again, maybe 200, 300 sensors every 10 seconds, plus our own calculations feeding that database. Then you have a trove of, it's like a treasure trove in there. What we're trying to do here is to remember all that root cause analysis I showed about the tank and why it's happening. Again, that was done by one of our engineers, but this can be fully automated based on calculations, statistics, engineering, and with an AI layer on top to help us determine the patterns, the root causes, and the solutions. So again, I will not go into a ton of detail, but we can, with the AI, determine what's an event, identify when an anomaly happens based on the data and based on the models, and then identify the correlations and the drivers for those events. Then do the automated root cause and report that immediately, fully automatically to the operator. Right? This is why you're getting emissions. These are the reasons. This is what you can do about it. Yeah, so again, actionable advice is not just more charts and more graphs everywhere. It is now translating into actions. That combination, again, I'm not talking about throwing a ton of data into an LLM and expecting, a useful response. We're processing all that data through the model. We're doing our own calculators for, statistical analysis, correlations, all these things that calculators, we know how to do that. And then we're feeding all that at the very end to the LLM to create a narrative. So again, it's a lot of processing before you get to the LLM. So it understands the plant. It knows the flow diagram. It knows the connectivity. Every unit operation knows what they're doing, what's their purpose. So all that information is feeding the LLM. Yes, we've even been feeding control loops into the LLMs to help it understand that plant. Right, so this is very exciting. This is what we're working, again, at the ATC, trying to move this forward. We're currently deploying this platform at 6 different gas plants as part of a different project. So it's, again, super exciting times. We think this platform is going to be very useful to really track the emissions from tanks and from other sources. If you can imagine that, then at the end of the year, you integrate, you have your regulatory report as well. So again, it's kind of a nice way to bottom up and do a much more accurate tracking. So again, I think in terms of reductions, what we're seeing is that no CapEx, operational improvements. In this case, we estimate it's going to be around 40% reduction in emissions from tank venting, just again based on operational changes, right? So we think that there's quite a bit of potential if we can deploy this and scale it for emission reduction. Right, I think that's all I got. Good. Any questions? Maybe at the end. Yeah.
Yeah. Thanks, Albert.
Okay.
Thank you, Alberto. Next, we'll have our second presenter, and then we'll open it up for some questions if anybody has them online or here. I'm going to welcome up Philip Pinto from Envirosoft.
Okay. Well, thanks, Blake. Thanks, MELA. Thanks to Corinne for the opportunity to speak here today. Today we're going to be chatting about data-based approaches to emissions reduction. Just a bit about our team. Myself, I'm a senior technical advisor here at Envirosoft. Also joining us in the audience is Kaylin, our director of business development. And just a little bit of history about Envirosoft. We're a pioneer in the field of emissions management software. We've been supporting industry for over 2 decades. We're made by industry for industry. We were founded in 2003, and we launched our flagship product, Emission Manager, in 2004. And over the years, we've released and developed additional modules in close collaboration with our industry partners. In 2020, we became part of Constellation Software, an owner-operator of vertical market software businesses founded almost 30 years ago, publicly traded on the TSX under ticker CSU. And finally, starting in 2025, we have over 4.3 million barrels of oil a day associated emissions reported through our Emission Manager platform. Since our launch, we've partnered with over 100 oil and gas companies, not just in Canada, but also the rest of North America and internationally as well. Envirosoft has 4 main software modules that we use in order to quantify emissions. Our main module that we have is Emission Manager, which is our first product. It covers the calculation of greenhouse gases and criteria air contaminants from a variety of sources. We track emissions for tens of thousands of facilities across Canada and internationally. Fuel Flare Event Manager is our module that tracks and reports metered and unmetered sources of fuel flare and vent sources, and also deals with disaggregation of vent sources, useful for provincial regulatory reporting. Our NOx Manager module helps to support industry with regards to the federal multi-sector air pollutants regulation, which deals with NOx emissions from engines. And lastly, our Dehy Manager module helps with supporting provincial requirements in Western Canada to regulate benzene from glycol dehydrators. Over the years, there's been many challenges to emissions management. Of course, as we've recently learned, Canadian regulatory landscape is very complex and the pace of change is only accelerating. Additionally, within organizations, there's many different stakeholders, both internal and external, with differing priorities with the emissions chain of custody. There's also a lot of variety in the accessibility of emissions data and the quality of data that goes into these emission models. And lastly, we see increased scrutiny of reported emissions data by regulators and also by the public. So I'm going to be covering 3 different case studies here today that showcase how data is used in different ways in order to facilitate emission reductions across different organizations. So our first case study involves a compressor engine upgrade with an operator we were working with. This client had recently acquired an asset from a previous operator, and they were thinking of replacing some older legacy engines with some newer models. They believed it would reduce their emissions, but they needed some data to back this up before they could spend their capital. Their old equipment also had lots of issues with regards to fugitives and venting emissions over the years. Through our emission manager software, we were able to implement multiple emission models, establishing a baseline for their current set of data using measured process data, and propose future states, quantifying potential savings in fuel, reduction in methane emissions through methane slip, and with carbon pricing, evaluating financial impacts to their compliance costs. Without data to back up their claims, our client couldn't really go back to their leadership team with the evidence that these projects were worthwhile, they had quantifiable emission reductions that could be repeatable across their organization. Through the Emission Manager platform, we were able to model a 60% reduction in emissions in this one facility through decreased fuel consumption and methane slip. And we were able to secure confidence in the decision makers at that organization and the board to allocate capital towards future emission reduction projects. And since then, this client has been thinking of similar projects at other facilities, giving them assurance to their plans and using our system to model any future scenarios that came up. But one issue that can happen is if you don't know the data, you don't know where your emissions are coming from in the first place. So our second case study goes through this scenario. We're working with an operator who lacked confidence in their vented methane emissions. Their venting data was based on old estimates made by individuals many years ago, no longer part of the company, held in spreadsheets that no one really knew how to operate. With no consolidated view of all of their venting emissions at all of their sites, they didn't really know where to begin when it came to tackling emission reduction projects. So essentially, there was a lot of gaps in understanding where the opportunities lie. Through the implementation of our Fuel Flare Vent Manager software suite, we were able to implement detailed source level tracking for all individual vent sources at all of their facilities. And we're able to replace old, outdated calculations using old default factors with up-to-date information, including factors informed by measurement. What this really showed is that we can turn vent sources from a black box into a clear and auditable list, something that's really important when it comes to tracking your emissions accurately, and of course when it comes to dealing with provincial methane regulations. Finally, our third case study deals with a topic that's been talked about a little bit today with regards to data accessibility and transparency for emission reductions. We're working with a client that was tracking emissions in multiple spreadsheets and doing all of their calculations in multiple Excel spreadsheets with manually compiled files, disparate data sources coming from many different departments. Some of these spreadsheets were years old, some of them were only owned by 1 or 2 people who had knowledge of the whole process. It can create a bottleneck, and it is an issue when it comes to organizational alignment. And I love Excel, but it has its issues too. Without a centralized system in place that holds all emissions data, sources, and the tens of thousands of data points that go into emissions calculations, it's very difficult for organizations to collaborate or validate the data that they have. So in this case, we were able to implement Envirosoft's Emission Manager tool, our flagship product, in order to centralize their emissions data into a singular platform. From this, they are able to actually make insights as to where their emissions are coming from. They are able to answer simple questions that they couldn't answer before from all of their spreadsheets. Simple questions like, what are my top emitting facilities? What are the sources at our facilities that are driving our carbon intensity? What facilities of mine actually have the highest carbon intensity? It seems like it's pretty simple stuff, but a lot of operators we worked with in spreadsheets have no idea how to get some of this information because only a few people know how to work those sheets. And finally, what's the impact of changes that people in the field make on my emissions? When changes happen, are we actually seeing emission reductions occur? With another client, we were able to implement advanced API integrations in order to connect our emissions system to a data warehouse that they had. And through that, they were able to make a lot of data public within their own company and creating a lot of transparency within their organization. And what we found is that, and working with this operator, is that when you make the data visible within your organization, you create a lot of buy-in with your organization. People from all business groups in your company can actually see what are the emissions like at various facilities. People in operations or people in the field can see what am I actually working towards? What are the actual emission reductions that I'm implementing? What's the quantifiable number that I'm working toward? And we found that it created a mentality shift within that organization where emissions was not just something tracked by their emissions group, it was something that everyone wanted a piece of. It was a KPI that everyone kind of had to manage. And it really gave a lot of insight, especially to those larger facilities, part of the TIER program, insight as to when they're actually introducing some of these emission reduction projects, what's the financial impact to my bottom line with carbon pricing. So to summarize, in our first case study, the data gave the leadership team confidence to invest and to scale. In our second case study, it revealed what was previously unknown and enabled real methane reduction decisions. And finally, in our last case study, we showed that data transparency can change organizational culture and create buy-in besides the emissions team. When you understand your emissions, trust your data, and make your data accessible, you can turn methane reduction into a pretty real actionable item. And just a bit more information about Envirosoft. We're Calgary-based, and we've been working with lots of different operators internationally and in North America, consistently working with operators hand in hand to develop new and further products. So, thanks.
Thank you to you both. Now it's time to put you on the hot seat. This should be fun. Maybe we should get Wayne up again. Wayne was good at that job. So I'm going to throw one out there right to Philip right away, just because something triggered on one of your last slides that you were talking about. The impact of what operators can do in the field. And I think this is very important that we recognize that they are an integral part of any operation, right? Those are the guys with their boots on the ground. But they can make some decisions out there that can negatively impact emissions. They can also make decisions that they don't know positively impacts emissions. So I'd love to hear, how do you think that we can work alongside operators and inform them that those changes can impact emissions and try to help them make those good decisions?
Yeah, it's a great question. We've worked with lots of different producers, and honestly, education is one thing that we have dealt with. Like, you know, we deal with a lot of emissions teams, and they deal with the operators. And really, it's a mindset of how can we provide the knowledge of, you know, what exactly provides a good outcome when it comes to emission reductions. We've had people on operations team wanting more information, you know, starting with this transparency stuff. Once they start to see the information, they want to know more. How can we actually help? Like, what can we do that will help with emission reduction opportunities? So providing like some insights there is what we tend to do. And giving them just some brief notes, kind of, you know, especially with large facilities that deal with carbon pricing with TIER, just how small changes, you know, small reductions in fuel or flare, vent savings can result in actually meaningful dollars saved.
Alberto, any thoughts on that?
Yeah, no, and like I was saying, and we're working, again, part of the ETC effort is, I think we need to bring that data right into the control room. Again, when we are similar to my colleagues, you know, issuing reports for regulatory or, you know, that's not timely, right? So again, we'll love to see additional screen in their control rooms that have this information in these recommendations and how it impacts, because that's when they're going to be able to really act on it, right? Yeah.
Yeah, and most emissions are going to be invisible to the naked eye, so it's really hard to inform those decisions unless you can see it like that, right? Alberto, just back to you again. So in addition to the methane emissions and root cause analysis for tanks, what other applications does your platform have?
Yeah, I mean, again, there's been a lot of interest in methane emissions from controlled tanks. That's kind of what's been driving a lot of this activity. But very quickly, we got into energy. Because again, if you think about this simulation model of the whole facility, to get to combustion emissions, for example, not so much venting, but these other energy-related emissions, we're tracking those anyway. So again, the KPIs that can be added, not just for emissions, but for energy and even for process optimization, they follow very quickly, one after the other. You know, in one case, we've been looking at tracking hydrate formation and methanol injection. Again, a little bit far away from emissions and energy, but the model is already doing it, right? So again, adding more KPIs is going to be interesting where this goes.
Well, and that's very interesting, because something that one of our other panelists today, Steve Frohler, who's still in the room, really harps on is the more efficient use of chemical. So if you can predict that, you can predict your use of chemical further. That's great. Philip, what trends are you seeing in industry from operators managing their emissions? What are you noticing out there?
Yeah, I think the biggest thing is wanting to move towards a centralized system, not just for their calculations, like a software tool, but also trying to group together all their information in one place. We're working with an operator who's multinational and getting all of their information into a data warehouse called Snowflake. And it's pretty powerful to be able to have all of your meter data, your operational data, all these hundreds of thousands of data points that are coming from various places, putting it into one centralized warehouse where you can actually start to make these analytics, make these conclusions from the data that's there. So kind of improving that sort of data collection is something that everyone's trying to strive towards, is what I've seen. And wanting more insight into their emissions data as a result of that. Getting conclusions from their emissions data that they can use for reduction projects, not just checking the box that they've submitted a report at the end of June.
So let's go deeper on that one. So we've got oil and gas. It's a vast operation, right? Even if we just look in Alberta, the difference between operating in Medicine Hat or north of Bonnyville or Grand Prairie. I mean, you're covering a very vast area and multiple different operations, different process types, different operators. I mean, I've seen, you know, how multiple people can spell the exact same word wrong, let alone get the data a little bit wrong. So how do you know, ensure that, or how can companies, I guess, ensure that they're getting quality data, not just quantity data?
I guess there's a lot of things they can do. I think one of the top ones is actually having like buy-in from the people providing the data, that they actually care about what they're giving you. They're not just giving you recycled information that's not relevant. Kind of having multiple stakeholders involved in the data process, you know, reviewing for anomalies, introducing things like AI to see if data quality is actually good. As we have like hundreds and thousands, millions of data points coming in, like, can we actually review all of that data? It can't be done by a single person. You need to have processes in place in order to actually kind of vet that data is good.
So you're saying just an Excel spreadsheet isn't good enough? That might not get you there. Alberto, any thoughts on?
Yeah,
on
no,
that?
definitely. I think you know, that's been a challenge and will remain for some time, I think. I mean, like Philip mentioned, there's a lot of investments going on in industry to create those data lakes or those data fabric, you know, environments where everybody's got access to the data. But that's going to take some time. And in our experience, again, for the platform that we use, for the regulatory, for everything, something we definitely need is flexibility, because every company has a different system, data management practice. Even if they use the same softwares, they may be using it differently. So when we're setting up something, we need to be flexible. There's no standard way of doing it yet. Maybe in the future there will be. But right now, we just have to be super flexible. Like you mentioned, develop interfaces to different products, different ways, and you know, just get the data that way.
So could AI play a big role in that?
I don't know. I mean, it definitely can play a good role in checking data quality. You know, running all this. You know, I'm stuck in the past statistics, I'm thinking, but it's pattern recognition, right, in the data. But in terms of porting the data into an environment where people can access that data easily, I don't think AI is going to do that for us yet. You know, I think there's going to be a lot of work to set those environments, really.
Any thoughts on the role of AI?
Yeah, I think AI is very powerful. It's like the new thing that everyone's talking about the last few years. From people I've talked to, AI is pretty much an instrument, and how well you use AI is basically how well you're playing the instrument. And there's so many different ways you could use it. Again, like looking for anomalies within data, and pattern recognition is a big one. But also like providing analytics and even kind of predicting events that may happen based on data that you see. Those are potential applications of AI for the future.
Yeah, and just to qualify, I know like next to nothing about AI. About the only thing I can do with it is maybe turn a picture of my horse into a cartoon. That's about it. So, you know, this is a real question. Kind of one final question here, just to wrap things up. I know you can use data, and data can tell a lot of different stories. Sometimes you can use data and use it in a way that it just tells you the story that you want to hear. It can also tell the story that maybe you don't want to hear. So how do we get that story to be the one that it should be telling, not just the one that we want to hear or don't want to hear or want someone else to hear?
Let me have a go at that first. I mean, I think the way I'm thinking about it is when you establish data processing algorithms with solid rules in terms of, like I said initially, our models, with heat and mass balances, thermodynamics, kind of physics-based. And then you process all that data at the end with AI, then there's no room to cheat, right? Because physics, it's what it is. And again, if the answer is not something you like, then okay, it is what it is. So we're seeing that again, some of the venting situations we're seeing in tanks, it's more than we thought it was going to be. But that's the power of these tools, right? Take the data, process it rigorously, first principles, physics-based, and that's going to tell you a story. Yeah.
Yeah, kind of that saying, facts don't care about your feelings. So the actual facts in the data tell a story. And I guess you need to have some sort of good look when you're looking at the data so you don't kind of confirm your own confirmation bias. If I want to see an emission reduction, I'm going to start looking for cherry picking different data sets. So having multiple stakeholders involved in the emissions process is always a good idea, so that it's not just one person trying to find the one thing that makes them look good. So finding lots of different, there's so many data points. They all tell multiple stories. Maybe they all tell the same story, but having multiple people involved in the process helps a lot in terms of having independent and good data.
I was just thinking about that example of the truck venting. Again, we're looking at the data and we're baffled. It doesn't make any sense. Why do they pick methane? We cannot see anything. But then there was a story there, in that data.
No, and that's a perfect example. So, well, thank you both very much. I really appreciate it. Big hand for Alberto and Philip.
Well, thank you, everybody.
Thank you.